Welcome, everyone. Thanks for coming to listen to us. So my name is Dmitry, and this is my colleague Andrey. We work for MATLabs, which develops ZK Sync Era and overall ZK Sync stack. Yeah, and we came today to speak about security operations. So, and particularly real-time on-chain monitoring tools, as it is very critical, as was shown also by the previous speaker. So, but before we start, I want to invite some brilliant minds who are present here to participate in our code contests. Code for Arena, those are like the ongoing bug bounty program and just security contests that we are running right now. So feel free to participate, not right now, please, but probably just a bit later if you want to win some nice prizes. So yeah, today we're gonna go through the questions that are listed here. And for the first question, I'd like to invite my colleague to speak about it.
Okay. How many of you use the monitoring in your organization? Anyone? Okay.
Yes.
No.
I do. I work in security as well.
Awesome. Yeah. So why monitoring is important? Monitoring is our approach to security. It provides us the big number of the insights for our activities and for adoption of to the threats. So just think about that, and with this idea in mind, I will provide you some insights related to basic threats related to the smart chain and smart contracts area and the blockchains. So there are many threats related to the blockchain and the smart contract ecosystem. I just remind you about several of them. So first of all, this is the private key compromise. You need to understand that your private key is a master key, and if it's compromised, your funds can be easily withdrawn by the attacker, or even the attacker can take the ownership of your wallet and use it for any malicious activities that he would like to do. Reentrancy. So it happens when two contracts interact with each other. So the malicious contract do some specific functions that are vulnerable in another contract. So and use it for mostly for funds withdrawal. Oracle manipulation. So smart contracts are always fed with external data. So, and this data provided by the Oracle. So if somebody can manipulate with this data, so he can manipulate with the contract itself, and this contract might behave in any unintentional way. Denial of service, one of the popular, let's say, and probably the easiest implementation of the attack, when the attacker just overwhelming the contract's functions or resources, so the contract functions are blocked, or just provides the delays with the response. Front running. This is quite a sneaky attack where attacker using the transparency of the blockchain, and he can see when the specific transaction in the queue, and he can put his own transaction before your transaction if the fee will be higher than that transaction that he targeted. The last one, this is smart contract vulnerabilities. So this is flaws in the code which can be used by the attackers to hack the smart contracts and drain the funds or gain some kind of the authorized access there. So what can we do to protect against such threats? Basically, we have several protection measures. So first of all, this is the prevention measures. This is our initial activities and our first layer of the defense. We're using different solutions to implement access controls, to implement some checks, reviews, and etc., to reduce the common known threats. Next, we have a detective. Detective measures are our eyes. So using monitoring and anomaly detection features, we can analyze and find the malicious or some kind of unintentional activity in our networks. If the incident happens, so in this case, the corrective measures kick in. So we try to do everything we can to reduce the harm of the incident, to improve our layer of the defensive, and to update our approach and security response for the future. We marked incident simulations and response in the between of the protection, detective and correction, because it's like a bridge, because it provides you the ability to simulate the attack without any real harm. So you can identify your flaws, you can identify your problems. Based on that, you can make your own response and corrective measures for the future. So if such attacks will happen. So, and yeah, basically in this presentation, we mostly concentrate on detective and corrective measures. The main idea is that one of the measures cannot protect you against every threat. It can enhance one part of the security of your product, but it cannot protect it. Yeah. So the main point here that multi-layer security should be created by design. And just imagine that imagine it as a Swiss cheese. So each layer is a slice of the cheese. It has holes where the threads can go through. So, but when you stack everything together, there are not so many possibilities that the thread go through the all holes and will become as an incident. So the idea is to create as many layers as possible. So to achieve that, you need to think to start thinking about security in very early, even it wasn't rolled out in the production. So just also note that human errors are happen. The bugs can be found, and the most interesting part when the bugs and the human errors happen simultaneously. So you need to understand what to do in these cases. There is no way to avoid it. This is the main point that you should notice. So why it is important? In more than 10 years already, right, in crypto industry, there are many tools appeared in the helpful tools that provides us visibility of the chain, that help us to identify and monitor networks, products, and projects. So, but still, we see that incidents are happened. And most of the incidents, alerts happens within the huge delay. So let's review several hacks from the previous. One of them, quite recent one, is for the CoinEx. Another one related to 2017, it was the Parity wallet, multi-sig wallet hack. So does everyone knows about that hack? So do you read about that? Or okay. So basically, CoinEx hack. CoinEx is a crypto exchange, and this hack started from the private key compromise. First drain around 5,000 ETH was done in the middle of the day in the 30:20. All times stamps will be mentioned in the UTC time zone. So if you read some articles in the internet, it might be some different times, different with my presentation. So I just use UTC time zone. Basically, this drain very large, right? So, and if the company would have the monitoring system in place, this drain will be monitored and alerted to them. But nothing was implemented. So, and then hacker did different withdrawn using other cryptocurrencies. So like BTC, Tron, Ripple, and still those transactions are quite high. After 24 minutes from the first drain, the crypto security company, Cyvers, they tweet an alert about these transactions, and they tag the CoinEx account, official account there. And only after 4 hours from the event, CoinEx responded and made the suspension of the withdrawal. So the main idea here, so if the company would have the proper alerting, they couldn't mitigate or block the first withdrawal, but they could mitigate the next withdrawals that lead to around 70 million lost of the company. Next, it's quite an old one. This is Parity multi-sig wallet hack, July 2017. So this vulnerability was identified in the multi-sig wallet versions 1.5 and later. The attacker used this vulnerability to drain 3 wallets. I don't know, I think 3 wallets, right? So the first one was done on July 18th on 10:30 in the evening, approximately, and other 2 was done after 13 hours from the first one. So the main point here that the owner of the second wallet identify that their wallet was drained after 4 hours. So they check the attacker's address and they saw that these high transactions also hit that account. So they did a notification for the Ethereum Foundation and many developers groups about this issue and about this problem. And this group identified the vulnerability of the multi-sig wallet code. Here, the great example when the monitoring or alerting from one team could help the community, the crypto community in total. Because for this decentralized attack. Because to help to save the funds, the White Hat group did the same hack for more than 590 wallets that were vulnerable, and they saved around more than $81 million for the community. So yeah, they did a notification about that after they finalized it. So, and everyone could claim their funds from these saved wallets. Meanwhile, Parity team did the update of their contract and the fix the vulnerability. So in the end of the day. So once again, as we mentioned right in the beginning of this conference, that we are making the community. So, and alerting is not the, let's say, only the problem of the one company. Alert should be available, when monitoring should be available and done by every company. So, and these feeds and information should be shared between the community. So that is how we can reduce the number of the hacks and reduce the numbers of the stolen activities. So, yeah, I will provide the microphone to Dmitry. He will provide you details about what to monitor and how to monitor and what tools can be used.
Thanks, Andrey. Yeah, so basically, as was mentioned, I just want to add a couple of words to the previous slide. As was mentioned, the community effort is very essential, and it builds the overall trust in Ethereum, in crypto, and helps the adoption. That's why building the proper monitoring in your company, in your project, you would contribute to the overall security of the community. Yeah, so now let's speak about what we should actually looking for. So basically, it's all sort of the anomalies. So first of all, it's amounts. Amount of transactions and transactions amounts. Yeah, so because someone can be just drawing lots of funds from your contract by bypassing some security limits with the tiny transactions on gas fees, for instance. Or, for instance, you find out that someone just deposited a huge amount. Yeah, so your TVL grows dramatically. So maybe it's money laundering. Yeah. So next one is the transaction times. So imagine that you have script that, I don't know, equalize the balance between the contracts, just sends money from your hot wallet to your cold wallet. And this happens, let's say, every hour. And at one moment of time, there's a random transaction going to, let's say, the same cold wallet. An attacker just tried that the private key he compromised worked. It can be nothing. It can be done for a good reason, but it can be also a bad reason. These, anyway, have to be noticed and checked. Transaction participants and actually governance events participants. So let's say you have some spread with Shamir cryptography, for instance, or a multi-sig for voting. And for instance, you usually use three or five, yeah? And those three people are pretty much permanent, yeah? So the rest are the backup. Imagine that three of them, two backup persons, would be hacked. And the attacker can just use your backup against you. So if there's an unusual voter participating in the process, you should note that and just be sure that it's fine. And the transaction details. We saw actually a few events when the attackers and the code used a different transaction type, like legacy type 0, and type 2. And this is the technical side of things that is usually missed. You still should be very precise. So make sure that you determine what is the normal transaction for you. Smart contracts themselves are a bit different. So additionally, there are some common approaches right now to develop and to have certain governance events. Usually it's based on Open Zeppelin templates, for instance. What you should look for is the proposal creation, actually key governance events, I won't read it. Yeah, and any significant events for your contract. So if someone is minting your tokens, this is like, you should know about that, right? And if you don't have monitoring in place and you didn't do this, how you can know? Only with monitoring. Yeah, so now that's all cool, right? But what we can do with that? Because like building own tool set is quite complicated, but let's first of all check what we should keep in mind. So first of all, it should be separated. What it means? So just remember that your infrastructure can be hacked. And when I say infrastructure, I mean your computers, your servers, your phones, it can be hacked. And if you run the monitoring tool set on the same infrastructure that your project is running, then attacker can just turn it off. It also means that if you are large enough and you start thinking about the insider threats, or for instance, you want to consider the threat of a person being compromised in your team, kidnapped, for instance, then you should also separate the teams. Your monitoring team, the team who can configure the monitoring and have access to modify your monitoring, should be separate from the team having access to your normal infrastructure. Otherwise, there will be additional attack vector. Sorry. So it has to be reliable. Monitoring is not a vital part, but a critical one. So at least it should not go down without you noticing that. So have monitoring for monitoring. Very tense, right? Remember to document why you implemented some monitoring. Have the configuration somewhere in Git, for instance, and test your monitoring and test it again. As mentioned by Andrey, there are actually many ways to test it, including the simulation scenarios, but we will talk about that a bit later. And so what tools can help us to achieve that? So I'm here just talking about our experience, so what we use in Metal Labs, how we build the monitoring for us. So first of all, it's API of the smart contracts, of the chain, of our ZK Sync Era API. Second is the Open Zeppelin. Open Zeppelin is a great tool, we will speak about it a bit later. There are some alternatives to them as well. Yeah, so these SaaS monitoring tool sets allows you to configure many things in few clicks. Yeah. GitHub, a free way to store your configuration. They have actions. You can, in many ways, just deploy your configuration in few clicks, and you can configure it separately from your infra team. Portabots. Portabots is a huge step forward. So this team actually built quite good, reliable solution for monitoring. Unfortunately, they don't currently support zk sync error, but hopefully it's gonna come soon. But for now, the major use case for us was monitoring the L1 part for our ecosystem. And Grafana, Prometheus, and other tools like PagerDuty, I don't know, Ops Genie or whatever escalation and incident management tool you are using. Yeah, so about the Open Zeppelin, as I promised, there's a separate slide. So they fully support zk sync. So Open Zeppelin overall is the MATLAB's partner for the security solutions. And we work with them very closely also for the security audits. So what the product does, it monitors basically all the events happening on multiple chains. You can filter out and put some logic inside. It can be a simple one. You can also integrate it with the porta bots if you need some advanced logic. Then it can just escalate to your PagerDuty, Ops Genie. It also supports webhooks and so on. And if you are not very techy, they have GUI, which can help to configure the basic configuration just in few clicks. So overall demo of the product is available from this QR code. If you don't use them, I highly recommend you to just check it out. And the Defender has actually a lot of other cool security features aside of monitoring, like deployment of the contracts, blah, blah, blah. So just check it out. Yeah, so in order to give you a quick start, I've prepared some basic, very basic sample of the code. It includes the GitHub Actions, which can deploy the configuration. It includes the very simple ERC20 token, and it gives you an alert to your email. So yeah, but you can easily just kickstart from there. So, okay, we detected it, yeah, so we received an email. So what we gonna do? Just imagine your engineer receives a call in the middle of the night. Okay, private key is compromised. What? I wanna sleep, yeah? So be prepared. It's a very simple answer. So think about the key attack scenarios and possible response that you want to have in a predictable way. Write it down. It's very important because in the middle of the night, under a huge amount of stress, people make mistakes and they do need notes. And test it. And test it again. Actually, the real life exercise with the limited knowledge, like simulation of the hex scenario, improves the incident response a lot. But I can tell you for sure, you won't make friends like in that way. A small heart attack is still a heart attack. And I can tell you, as I was the participant of one of such exercises in MATLABs, but I was not aware. Yeah, I was thinking to resign even. but it goes away after the stress is gone. Yeah. So and identify a document how you're gonna mitigate the most significant threats. Like, what are the conditions under which you want to pause your contract, or you want to implement additional delay? Maybe you want to even automate part of that. Like if you get the alert, a script is executed, then publishes the pre-signed transaction to pause your contract. This will help with these scenarios that Andrey demonstrated. like with hours or like between the first withdrawn money and the actual incident response. So, well, so what's next? Yeah, so we are going to the decentralized world, and all the tools, nearly all the tools that I mentioned, are pretty much centralized, yeah? So, to be honest, I don't know the answer. And if you know what to do, so I have some ideas like creating a DAO with the cool security people who stake their reputation there and actually do the community response to the incidents. It can be a case. So let me just invite you for some discussion. Yeah, so if you have ideas, please feel free to share. Yeah, we are available somewhere there. Okay, thank you.
All right. Thank you very much, Dmitry and Andrey from MetaLabs. Talking about a very important topic about real on-chain monitoring. It's indeed very important for anyone developing any protocol. You never know when hackers might come in and sneak away with your funds, so always have to be careful. Okay, I quickly open for any questions. Anybody have a question? Please raise your hand. Just wait for a moment, guys. Anybody, feel free to raise your hand. No. What do you think was the worst hack in crypto so far? The most terrible hack? Oh, it's switched off. You can switch it on. Just press the button there. Is it there? The worst, what in your opinion was the worst hack?
I can definitely tell that the one when I had a mini heart attack.
Oh, okay. So that one was a test, right? Someone was testing your system. Okay. Okay, that's good. So everybody go and test your systems tonight. Just don't tell your developer and see what happens. All right, otherwise let's give them a round of applause. Thank you, gentlemen. Dmitry and Andrey.